and welcome back to Multiple Regression Analysis. This is part 2. In this video, we'll learn how to run a regression using the Excel analysis tool pack and how to read a regression output, or at least some of it. In the last video, I showed you how to set up a spreadsheet with your dependent variable on the left and your independent variables on the right. We use those to set up our model equation, which acts as a placeholder for the time being. Now we can take this and use Excel to analyze the data. Okay, here I have my spreadsheet, and I'm going to go over here and click Data. That'll bring up a menu, and over on the right is the Data Analysis tab. I'll scroll down here and find Regression and click OK. Let me just move this over so that I can see what I'm doing. Okay, now for the Y range, that's my dependent variable. I'm just going to highlight that. And then for the X range, that's all of my independent variables. So I need to highlight that whole chunk of data. There we go. And I'm going to click Labels because I actually highlighted the labels also. And I'm just going to label this, it's going to pop up a new worksheet. We'll call it Regression Output. And I hit OK. And there we go. There's the regression output. It's that easy. I'm just going to move some of these things over a little bit so I can see the words. Yeah, and maybe this over here. Whoops. Okay, there we go. Now let's go analyze this bad boy. Okay, here's what the computer spit out for us to read. Now at first glance, it can be really intimidating. But I've highlighted a few things that we really need to look at. So first thing, that says significance F. This is the p-value, or the significance, for the entire data set. If this number is below 0.05, then that means something in my data is significant somewhere. I don't know where yet, but we're going to find out. In this case, the significance is 0.002, which is definitely less than 0.05, so we can continue with the analysis. So let's move down to this column of p-values here. These are the p-values of the individual independent variables. So we need to find any that are not significant, or any whose p-value is larger than 0.05, and we need to eliminate them one by one, starting with the highest one. In this case, it looks like area has the highest p-value, so we need to take it out and run the regression again without area. So I went ahead and did that, and here's what I got. This is the new output, and notice the significance of F has changed, but it is still well below 0.05. In fact, it went down. So we're just going to keep chugging along here. So again, let's go look at the column of p-values, and we need to find any that are not significant, which are any greater than 0.05, and eliminate the highest one only. In this case, it looks like literacy has the highest p-value, so we'll take out literacy and run the regression without it. And here's what I got this time. And we're just going to go through the same process again. We'll find any that are not significant, any p-values that are greater than 0.05, and again, eliminate the highest one only. Oh dear, oh look at this number. Okay, if you ever see a number that looks like this with an E and a negative number behind it, that's scientific notation for a really small number. So keep it. It's a p-value well below 0.05. So we still have population with a p-value above 0.05, so we'll take that out and run the regression again. Let's see what I get. Okay, here we are. Let's check out the p-values, and look at this. All p-values are now below 0.05. So we get to stop. Yay! Okay, now let's check out this other number that's been sitting up here this whole time. It's called the adjusted R-square. You can see that it's 0.459. And what that's telling me is that 45.9% of the variation of life expectancy is explained by the variables in this regression. So really, we're missing more than half the story. No worries though, it doesn't mean that we failed, it's just information that we need to consider and acknowledge at this point. So let's go back to our setup from the beginning. Now is when we get to deal with that placeholder equation that we made. We've got our final regression here, and remember, we've eliminated literacy, population, and area because they weren't really significant to our factors in life expectancy. And now we get to bring in another column of the information, the coefficients column. This column will help us write out the actual regression equation. So the intercept here, that's also the constant, and we'll make a shortcut for urban and call it x1, and we'll call GDP per capita x2. It just makes it easier to write out later. And actually, now you're looking at the equation, but let's just type it out like this. We have life expectancy equals 54.288 plus 0.233 x1 plus 0.00013 x2. Voila. Okay, it's not too exciting just sitting there, I agree. So, you know what? We'll take it for a test run. Let's see if we can predict the life expectancy of a few countries. We'll start with Norway. So I looked up the information for Norway and I found out that the percentage of urban residents is 81% and the GDP per capita is $54.5 thousand US dollars. So I'm going to plug those numbers into my equation like this. See, I put 81 in for x1 and the 74.5 thousand in for x2. So I just plug and chug with a calculator and I get the life expectancy in Norway to be about 83 years. But remember, the adjusted R-square was 0.459, so this is less than half the story. Still, I was curious about how close I got and looked up the actual life expectancy in Norway, and it is 82 years. Wow, I got pretty close. Sweet. Okay, let's try another one. Let's go to another part of the globe, Argentina. Same process here. So the percentage of urban residents is 92%, and the GDP per capita there is about $12.4 thousand. So I plugged that into the equation, 92 for x1 and 12.4 thousand for x2, and I found that the life expectancy in Argentina should be about 77. Keeping in mind, of course, that we don't have the whole story. And shall we see how close I got? It looks like 76 is that current life expectancy. So again, we got pretty close. And that's it. That's the 40,000 foot view of how to run and read a regression. We could certainly go deeper into the analysis, and we should, but we'll stop there for now. But it's really cool, isn't it? Well, I think so anyway.